From water tanks to containment vessels for the petrochemical industry, pre-stressing has become established as the ideal construction method for the control of forces generated within these structures. The highest level of this technique is employed in the nuclear industry, an area with the severest specifications, with no margin for error, as illustrated by the exceptional safety requirements that the containment vessel must meet in order to protect the reactor and protect us from the reactor. For example, the concrete shell containing the reactor must be able to withstand the impact of a crushing plane and also resist the pressure of escaping gas in case of accident. This results in a reinforced concrete cylinder closed by a dome culminating at 80 meters or so, the whole structure being internally strengthened by steel tendons with a possible total weight of nearly 1,500 tons. The metal reinforcement follows a strict pattern reached by the juxtapositioning of vertical cables, horizontal cables, and skew-curved cables within the thickness of the dome. This extremely intricate mesh is considerably complicated due to the exceptional density of the reinforcement and because of the presence of numerous openings left in the wall. The preparation of the ducts in which the tendons are inserted and the pre-installation of the anchorage parts, which are later embedded in the concrete, are carried out in the workshop. As is the assembly of the steel cages composed of modular elements. Thanks to this particular design, the gigantic puzzle can then be directly assembled on the site. All the transportation, handling and installation operations are thus greatly simplified. In the straight or slightly deviated sections, the tendons are installed in flexible ribbed steel sheaths. In the more delicate areas, geometrically speaking, they're housed in rigid tubes which are previously curved on a bending machine, then bell-mouthed at their ends in order to ensure a perfect fit. The watertightness of the connections of these various parts is ensured by means of heat-shrink polyethylene sleeves. There's no room for the slightest error in positioning and layout, which are subject to minute control and stringent verification. Once this series of steps is completed, the network is ready to be fitted with the pre-stressing tendons. A careful choreography which starts with the threading of the tendons unit by unit. Then comes the tensioning operation carried out by means of powerful hydraulic jacks. This meticulous phase is completed by cement grouting, thus ensuring the protection and permanence of the tendons. After decantation, an additional grout is necessary to ensure the complete filling of the ducts. On the site, threading is achieved by insertion of the strands with a threading machine, the strands being regularly fed from a coil housed in a strand dispenser. In certain cases, as we see here in Turkey on the Ereklesi liquid natural gas terminal site, the more elaborate cable path calls for the pre-assembly of the bundle of strands, which is then pulled into the ducts with a winch. After cropping the end of the tendon, the anchorage block is installed and then the wedges are positioned. The jack is then activated to tension the tendons, developing a force of up to 1,000 tons. Throughout the process, all the elongation and pressure parameters are obviously strictly controlled and recorded. The grouting can then begin with the installation of watertight caps on the anchorage heads. This ultimate phase requires the preparation of a specific cement grout, generally of the retarded type obtained by the addition of special admixtures. The grout is then pumped into all the ducts, each phase being minutely controlled. In addition, Freycinet carries out surveillance and maintenance missions. Here at the ASCO plant in Spain, the tendons are extracted and cut in 1-meter sections which will be delivered to the laboratory for examination. With its experience acquired on the construction of more than 80 vessels, not only in France but also in Great Britain, in Belgium, Spain, Pakistan and India, and just recently in Daya Bay in China, Freycinet is today the top pre-stressing company in the world. Its active participation from the beginning in the French nuclear power program, in association with the French Electricity Board, has led it to establish an active internal quality organization. The client is thus assured of scrupulous compliance with contractual and regulatory requirements in perfect harmony with the specifications.